Fairly early on, scientists in chemistry discovered that they were dealing with particulates that were so doggone small that they had to develop a system of managing them. Let's talk about the creature called the mole. Now, this creature, the mole, is a creature which always possesses, at 1 mole capacity, so they devised a creature called the mole, which has 6.022 times 10 to the 23rd molecules, atoms, particles. A full mole always contains that many of those. Now, that's fun to arbitrarily decide on a capacity. Remember, we bumped into this capacity before with Kelvin. When they set the term Kelvin, they purposely set it to where you could not have negative numbers. And in this instance, they set it purposely to be all-containing. But again, you have to have a realistic and a solid basic reference point, which in temperature was 273.16 Kelvin. 0 degrees Kelvin. 273.16 is, again, 0 degrees centigrade. In this instance, they used something which had long been around and paid the price as tried and true. They decided that the mole, mass-wise, would equal to the molecular mass the atomic mass or the particulate mass. Now, the way that works is pretty simple. Take a substance which is near and dear to my heart, you've seen many times, water. A mole, we'll shorten it to MOL, of water is equal to 6.022 times 10 to the 23rd. Because it's a molecule, we say molecules. And it's also equal to the mass in grams. Hydrogen's 1 plus oxygen, which is 16. Give you 18 grams per mole. Now this works out for every substance. Obviously, the molecular weights will be considerably larger at times, but this is the basis for chemistry using the mole. So we develop our molar concentrations based on this, and we spent a lot of time dealing with mole, especially in water chemistry, which is, and general chemistry in particular. So the mole concept is that which you will use many, many times during the general course.